Alright, in this video we shall look at global extrema for a function. I still remain your presenter, Dr. Okekikina Steven. Minima and maxima are collectively known as extrema. Considering this diagram, we have that this diagram contains the relative extrema and global extrema. On this diagram, we can see global maximum, we can see global minimum, we can see local maximum, we can also see local minimum. Now, this graph is defined on the interval 0.1 to 1.1. So at this point, the function at f of 0.1 gives a global maximum, and also that of f of 0.3 gives global minimum, and also between the interval of 0.4 and 0.8 we have a local maximum which corresponds to f of 0.6. So at this point, between this interval 0.8 and 1.1, we also have a local minimum. So this interval 0.1 and 1.1 contains sub-interval such as 0.8 and 1.1. So at this point, we have the local minimum, we have the global minimum, we have the local maximum, and also the global maximum. Now let's reflect this class with the previous video by looking at the relative local maximum of a function. A function f has a relative or local maximum at x equals to b if there exists an interval, a closed interval containing a and c, such that for any x in the interval we have that f of x is less than or equals to f of b. Also, a function has a global or an absolute maximum point at x star if f of x star is greater than or equal to f of x for all x. A function f has a relative or local minimum at x equals to b if there exists an interval, a closed interval containing a, c, such that for any x in the interval we have that f of x is greater than f of b. Also, a function has a global or absolute minimum point at x star if f of x star is less than or equal to f of x for all x. Functions do not necessarily have extrema in them. For example, any line f of x equals to mx plus b, where m and b are constants, does not have any extrema, be they local or global. For instance, example 1. Let's look at this example 1. F of x equals to x minus a all raised to power 3 plus c. So we look at the first two derivatives of this function. So the f prime gives 3 times x minus a all raised to power 2, and second derivative 6 times x minus a. Since both derivatives vanish at x equals to a, we consider the third derivative. And differentiating this to have the third derivative, we have 6. The stationary point x equals to a is neither a relative minimum nor a relative maximum, since the third derivative is finite. Now, example 2. Considering this diagram, we have a closed interval. For instance, we have minus 2.5 and 2.5. Also, between this interval, we have sub-interval between 0 and 1.8. So at this point, f of 1 we give 2, and f of negative 1 we give negative 2. So at this point, we have that At x equals to 1, the corresponding value of x equals to 1 gives 2. So that is the maximum point. For the minimum, we have that at x equals to -1, we have that f of -1 will give -2. So at this point, the graph attains a local maximum at a point 1, 2 because it is the highest point in an open interval around x equals to 1. The local maximum is the y-coordinate at x equals to 1, which is y equals to 2. So at this point, x equals to 1, taking f of 1 gives 2. So at this point, that 2 is the local maximum. Example 3. Find all global maxima and minima in the graph above. Also, considering the interval -2.5 and 3, we have that a function at -2, that is x equals to -2, gives f of -2 equals to 16, and also f of 2 gives 16. So at this point, we have that f of 2 equals to 16 and f of -2 equals to 16. So at this point, x equals to 2 and x equals to -2 gives they give 2 maximum points. So at this point, the graph attains an absolute maximum in 2 locations, x equals to -2 and x equals to 2, because at these locations, the graph attains its highest point on the domain of the function. Also, the absolute maximum is the y-coordinate, which is 16. The graph attains an absolute minimum at x equals to 3 because it is the lowest point on the domain of the function's graph. The absolute minimum is the y-coordinate, which is -10. So at this point, we have that at x equals to 3, we have f of 3 will give -10. Alright, applications. Minima and maxima are used in artificial intelligence. In artificial intelligence, we may want to discover what the least costly plan of action to take is for a robot. That is the shortest path. Ideally, we want to find the global minima for the plans. However, because there is not unlimited time to identify the right plan, artificial intelligence often simply finds the local minima. Thank you. Please subscribe to my YouTube channel for more videos.